Hey everyone, welcome back to Java Collections Framework playlist. This is Maddie. In our previous video, we understood the overall architecture of the Java Collections framework. Today, in this video, we are going to explore one of the most frequently used collections in Java, that is ArrayList. Almost every Java developer uses ArrayList, but very few understand what happens internally when we perform operations like add, remove, get, contains, clear, and so on. By the end of this video, we will be understanding every important internal concept of ArrayList that is frequently used while programming or that is frequently asked in an interviews. So let's begin with our first question. What is ArrayList? ArrayList is nothing but a resizable array implementation of the list interface. We have discussed in our previous video that ArrayList is a class which implements list interface. And the second point here is internally, array is nothing but a group of objects. You can say it as collection of objects. Many beginners think ArrayList is some magical data structure. No, it's not. Internally, it simply contains array of objects. That's it. So whenever the question is asked what is an array list, you could easily say it is a collection of objects. That's it. It is so simple. Now let's see the internal variables of ArrayList class. These two variables are most important. Whenever we declare an array, we need size, right? To mention it here. In the same way, in the ArrayList class, it will be having a variable called int size. And one more thing, as I have mentioned, ArrayList is nothing but a group of objects. It will be having an object array with a reference variable, element data. That's it. These two are the declared variables inside ArrayList class, wherein element data is nothing but internal array that stores the actual elements, whereas size defines the exact number of elements currently stored inside this element data variable. I hope this concept is clear. Let us see how we can define an array list now. We will be having a data type which is nothing but array list, and within this brackets we will be passing the actual object data type of elements of this array list. This is nothing but a reference variable, meaning the reference name, and this could be anything, and we just need to instantiate the ArrayList class. This is how we declare an array list in Java. Whenever the program encounters this particular line, it mainly does two things initially. It will define an object array by a reference name element data with empty bucket. There will be no elements inside the element data object array. And one more variable that gets initialized is a size variable, initially with a 0 size. I hope this thing is clear. Let us see what happens when we create array list. Meaning, whenever we create an array list in Java, most people think Java immediately creates an array of size 10, which is wrong. Modern Java versions create an empty array as we just now discussed. It will literally create an empty array with a size 0, because the simple reason is, why to waste memory when there is nothing confirmed that this list might or might not be holding the elements inside it. Then why to waste memory for 10 objects, empty objects, which are of no use? That's the simple reason why initially Java creates an empty array. Then the next question is, when will it allocate a memory to it? To answer that question, whenever you just add first element to the declared list, it will create an object of array object of 10 objects inside it, and it will allocate the current element to the first index, meaning the 0th index. That's how it happens. After all these things, you might be having a question, how array list is dynamic? We are not at all passing the size here. How is it getting this size variable incremented, or like how it is getting decided that this size variable should have a particular number? Let us see that now. Before we go into that point, I want you to understand the difference between the capacity and size. Let's take, we have an array of objects, null or empty. Let me just mark them as empty. Now for this array, what is the capacity and what is the size? Pretty simple. Capacity is nothing but how much an array object can hold. It can hold 1, 2, 3, 4, 5, 6, 7, 8. So the capacity becomes 8. Size is nothing but what is currently being held. 1, 2, 3. 3 elements are inside the array object. So size is nothing but what is currently being held. Capacity is nothing but what it can hold, meaning the maximum capacity it can hold. Now this thing is clear. Let us see the dynamic behavior of array list. Let me just declare array list again. Angular brackets, string list equals new array list. When Java encounters this line, what it does is it will declare an element data variable with an empty array and size initialized to 0. And now you decide to insert an element inside list now. That's our first element, list dot add. I'll just add okay, so we just need to pass the string data type. I'll just pass my name whenever Java encounters this particular line, what it does is it will just update element data variable to the initial capacity of 10, and it will update the first element to the element whatever we are currently passing, which is nothing but Maddie, and update the size variable to 1. This is what happens when the first insertion happens. Now let's take, you just insert some more elements to it, Java, and so on until the size 10. Let's consider we are just inserting 7 more elements between Java and list. Just add them here, Java, and the last element we have is list. This is our 10th element. This is our second element and the first element. Now, whenever you try to insert the 11th element inside, what I can give here, let me just give it as Q. Now, whenever you try to insert the 11th element into the list variable, what it does is the Java creates a new larger array. What will be the size of it initially? Which is nothing but it will just increase the element data size to the current capacity multiplied by 1.5, meaning our current capacity is 10. The size is also 10, current capacity is also 10. So 10 into 1.5, which becomes 15. So Java creates a new element data array of initial capacity 15, and then what it does is it will copy all these 10 elements into the newly created array. Once it copies all the elements from the old element data, the 11th element gets inserted at 11th position, meaning we will be having the last 4 positions empty. With this, size gets updated to 11 and capacity remains 15. Here we will be having Q. The last 4 elements will be empty. I hope so far the things are clear. And now, even after completing all the 15 elements, whenever you try to insert, let me just take car. Whenever you try to insert an element at 16th position, it does the same thing. The capacity will be 15 and it just multiplies with 1.5, and then it creates a new array with this size. 15 into 1.5 is nothing but 22.5, and this gets rounded off to 22. So it creates an array of size 22 and it will copy all the 15 elements into the new array, and then it insert the car element at 16th position. This is how the cycle goes. Whenever the list is filled with all the current capacity, and when you try to insert a new element into the same list, what it does is it will increase the current capacity to its 150 percentage, meaning current capacity into 1.5. This is how dynamic allocation happens for ArrayList. I hope so far the concept of ArrayList is clear. If you have any doubts, please do comment it. We'll try to answer all of the questions. Now we have understood how ArrayList works. Let us see the time complexity of few important methods of ArrayList now. The first method is add. Add is nothing but, as the name itself suggests, inserting an element into an array, meaning the new element into an array. That's it. We have two cases here. Case 1 is nothing but the space is available, meaning while inserting, the space is already available inside an array list. So what Java does is it will just directly allocate the current passed element, which is nothing but the current input element, to the available space, meaning the next available index. The time complexity of this is nothing but constant. We have space available, it will just directly insert an element into the available space. So the time complexity of case 1 is nothing but we go of 1. Again, if you have not watched my time complexity, space complexity playlist, please do watch it to understand what is big O, big omega, big theta, and all those things. Case 2 is when space is not available. As we have discussed, capacity was 10, and now all the elements are inserted. We are trying to insert 11th element. What happens in this case? Try to answer by yourself. The resize operation happens. As we have discussed, current capacity into 1.5, and it will just create a new array, copy all the elements from the old array into the new array, and all those stuffs happen in the background. So that resizing and creating a new array and copying all the elements from the old array takes n time. The time complexity of case 2 is nothing but n time, big O of n. Now considering both the cases, the overall average time complexity of the add function is nothing but amortized big O of 1, because we don't always resize the array, right? And this happens only when the current capacity is filled. So we are just considering it as amortized big O of 1. So this is very important topic for interview. The second method is get. Get method actually takes index. As the name itself suggests, get is nothing but pulling the data from list. Whenever you do list dot get of 0, internally what happens is it will just return the 0th index of element data variable. That's it. I don't think I need to explain this part, returning element 0th index of element data. Since we are providing the index, it immediately reaches to the exact position and returns the element. So we can easily say the time complexity of get method is nothing but big O of 1. This is the reason ArrayList is very fast for retrieval. I missed to mention one point. In the add method, we have two ways of adding. So we can directly pass the element that we need to add, or we can also pass the index where we need to insert an element into. Just write this element. This we have discussed. The time complexity of this is nothing but amortized big O of 1. But what happens whenever we add at particular index? We have already discussed this in our array playlist. Please do watch it. Whatever I'm currently explaining, we have already discussed. Let me just take up an example over here. Let's consider we have an array of objects and indices 3. Let's imagine we just need to insert an element here. List dot add at index 2 an element 100. What happens whenever Java encounters this line? Just try to answer it by yourself. If you watched my array playlist, then you already know the answer. What Java does is it will just iterate till the given particular index 10, 20, and it will just retain the same elements here, and at particular index at the given index 2 it will just insert the given element 100 and it will copy the remaining elements to its next position, meaning the second index goes to third index and the third goes to fourth. 30, 40. That's it. Pretty simple. And the time complexity of this is nothing but, if you have watched my array videos, then you can easily answer, which is nothing but big O of n. That's it. The same thing happens whenever you try to remove an element out of the list. Let me just show you that. Remove at particular index. Let's imagine we have 10, 20, 30, 40, 50. And now I just want to remove at particular index 2. 0, 1, 2, 3, 4. I want to remove the second index element. List dot remove the second index element. Try to answer this question now. What happens internally in Java? It will just shift the third index element to the second index and fourth indexed element to the third index. That's it. Pretty simple. It will just override the second index element with the next elements. That's it. This is our output. Time complexity remains the same, big O of n. In list, we also have a method called contains. So this method just answers whether the given element is present inside the list or not. Let's take an example. Same thing, 10, 20, 30, 40, 50. We just want to check whether the list contains the element 30 or not. What it does is, it will again start from the index 0. It will just do linear search of all the elements and checks whether the input element is equal to the iterating element. That's it. Internally, what happens is for each element, compare input with this element. If it finds, it will just return true, else false. Since we are doing linear search, the time complexity remains the same as remove. We go of n. That's it. Our next method is clear. As the name itself suggests, it will just flush out all the elements inside the array. Let's take again the same example 20, 30, 40, 50. Now I just want to flush out all these elements. I can just directly write a line list.clear. Internally in Java, it does for each element update the values to null. Since they are object, we are just updating the value of that particular index, meaning for each element, we are just updating with null. And size gets updated to 0. Even in remove, add, the size gets incremented and decremented. That's it. It's pretty self-explanatory. And once this process is completed, our array looks like this. An object array with all the null objects. And these null objects becomes eligible for garbage collection. That's it. Since we are iterating over each element, the time complexity is again the same. We go of n. Two more important points in ArrayList is we can insert a null value into ArrayList and hold null value. For this example, let's take we have 10, 20 and 30. We can add a null value in the next index. After this line, list becomes 10, 20, 30 and null. Even the multiple nulls can also be inserted into the array list. The second point is duplicate values. ArrayList can hold duplicate values as well. Let's take our current list is this. We can insert one more duplicate of 10, even one more duplicate of 20. After these two lines, ArrayList becomes they can hold multiple null values and multiple duplicates. One more important point about ArrayList is nothing but ArrayList is not thread safe. Don't worry about what is this thread and all. You will understand as we continue learning the Java. For now, you can just imagine them as workers. Let's take, we have a work M, and we just need worker A, worker B, and worker C to complete this particular work M. So in this example, these worker A, B, C are considered as thread. It's pretty simple. What is this not thread safe and all? You will clearly understand whenever we continue to learn more about Java. If you're curious to learn, just Google it, you will understand it. Just to summarize this video, ArrayList is nothing but a collection of objects. And whenever we initially declare an ArrayList, an empty bucket of size 0 will be created. And when you try to insert first element into this particular bucket, it will create initial size of 10 and then insert the first element with the given element, and then it will increment the size variable of ArrayList to the 10, which is initial size. And the time complexities of add function amortized big O of n, big O of 1, sorry. Then we discussed adding at particular index as well, which is big O of n, and pulling particular element from the array list, which is again big O of n. We also discussed remove, again same big O of n, contains as well, linear search, big O of n, even clear, big O of n. That's it. I hope this video is very much helpful. That's it for this video. In our next video, we will be seeing all these methods practically in IntelliJ. Thank you all for watching. See you in the next one.